There are some prerequisite skills that you need to have before you start the functions course, and I just want to go through those right now. If you do not understand what's in this video, I do not recommend starting the functions course because it will be very uncomfortable. I'm not saying that you cannot do it, but it will be much more comfortable if you understand the skills that I'm about to show you. The first thing that I want to make sure we cover is the concept of slope. So, slope is an element of graphing that you will use a lot when you're dealing with functions. And just a general definition of slope, it is generally defined as the steepness of a line. Now, we could do a very technical definition, but this is as good a definition as I'll need in this course. It is the measure of the steepness of a line. It can be positive, and a positive slope looks like this. It's low on the left end, low on the left, high on the right. I used to think of this or tell my students that that's a plane taking off. Not quite at that angle, that's too steep for a plane to take off, but the slope is positive. It is ascending. It's getting bigger from left to right. So can you visualize what a negative slope would look like? A negative slope, I'm going to go underneath, is high on the left and low on the right. So the plane is landing on a negative slope. So slope is a number. It will be the steepness, the amount of steepness in a line. Slope is denoted by the small letter m. Lowercase m means slope. And slope is found with a formula, and I'll go ahead and give it to you. Actually, I won't. Let's work on just the concept, and then we'll talk about the formula in the next section. So on a graph, I'm going to go ahead and draw a coordinate plane, and we will talk about this a little bit more in the functions course. We need to make sure we know our quadrants and all that, but for this purpose, I'm just going to draw a coordinate plane where this is the x-axis. I can tell you right now that my iPad is being difficult. And this is the y-axis. Y is tall. It's vertical. X is across. It's horizontal, like the horizon. And this point in the center is called the origin. That is 0, 0. Now, if you have no idea what I'm talking about with graphing, you need to stop this video right now and go back to your teacher and get some background before you try to do this. But if you're with me, we can take a step further. So I'm going to draw a function here, but we're just going to call it a straight line for now, and it passes right through the origin. It is continuous in both directions. And I can tell you just by looking at this graph that the slope is positive. The plane is taking off in this picture from left to right. So let's go ahead and put some more points on this line. I think I'm going to do a point right here, a point right here, and a point right here. Okay, and let's go ahead and give those points a coordinate. Let's go ahead and label. Oops, don't look at that. It's okay. I don't know what just happened, but we're not there yet. Let's give these points a label. So this center bullseye is 0, 0. We know that. This one is over 2. You always move on the x-axis first. So we're talking about moving over 2 squares and up 2 squares. Over 2, up 2. This one we have moved over 4, up 4. This one we have moved over 6 and up 6. So I want to show you something here that will help you understand the whole concept of a slope. Slope is defined, let me go ahead and give you these. Slope is defined as rise over run in a ratio. Now remember, we said that y is vertical, y is tall, so you're going to put your y value across your x value that's running across. So rise over run will help you remember about slope. And you will hear me use that term a lot in the functions course. So let's see where that's coming from. What's the derivative of that term? So follow me here if you want to do this with a red pen. I think that would be a great idea. So I'm starting here at the origin, and I'm going to rise to. Rise. Now in a coordinate, you do the x value first. But here we're going to rise to, and then we're going to run over to. Then from this point, I'm going to rise, and I'm going to run. Rise to, run to. And do you see what's happening there? This is essentially what slope is. I am building a staircase where all the steps are exactly the same. They have the same steepness. Can you imagine a staircase that you're walking up and then all of a sudden one step is steeper than the others or not as steep? What that would do to your balance? It's the same kind of concept that we're applying. We can also follow that same concept back down this line. So I would put a point here, a point here, and a point here. Okay, so that same stair step also applies in the opposite direction. So we would drop 2, over 2, drop 2, over 2, drop 2, over 2. So you see that the stair step follows the whole length of the line. And if the slope is a positive 1 down here, it's going to be positive 1 all along the staircase. So anytime you hear me use the term slope, visualize, picture in your mind the staircase. Now let's put the rest of our points in. We know that origin is 0, 0. I'm sorry, I'm having difficulties here. This is negative 2, negative 2. This is negative 4, negative 4. And this is negative 6, negative 6. Because to get here, starting at origin, I'm going back 6 and down 6. This one, I'm going back 4 and down 4. Back 2, down 2. No movement from origin. Okay, what I have drawn here in the blue line is a function. And that's what this whole course coming up is about. Now, there are different types of functions. That is called a linear function. So slope is simply saying it's a ratio of the rise value to the run value. So in this particular case, rise is 2, run is 2. Every time I build another step, I am rising 2 and running 2. And 2 divided by 2 is 1. Now sometimes slope will be in fraction form. Sometimes it will be in whole number form. You can have decimals. Slope can be 1.6 or 1.5 or 3/5 or whatever. It can be any number. It doesn't have to be an integer. But slope is always the ratio of rise over run. So if you're going up 2 and over 2, it's 2 to 2. Or that reduces down to 1. Okay, let's take a look at the slope formula, because you will, at times on a test, have to calculate slope using a mathematical formula. You probably need to memorize this one. I would make a flashcard or something to put this into memory. So the formula is slope equals, don't panic on me here, I'm going to walk you through it, y sub 2 minus y sub 1 over, remember it's always rise over run, x sub 2 minus x sub 1. This is called the slope formula. So how in the world do you use the slope formula? Well, the first thing you need would be 2 y's and 2 x's. And those are going to come from these coordinates that we have over here. I'm going to use these two just for illustration. Normally, I will use origin if it's in there, but this time I'm not. I'm going to use these 2 points. So I'm going to use 4, 4, and 2, 2. So let's bring this over here, and I'm going to go ahead and write those 2 points down. We have 4, 4, up 4, over 4, or over 4, up 4. And then we have 2, 2. So over 2, up 2. So I need 2 points to do the slope formula. If you don't have 2 points, you cannot do the slope formula. So you must have 2 points. And then I always encourage my students to go ahead and label their points. So it doesn't matter which is 1 and which is 2, but I'm going to say this is x1 and this is y1, and then this is x2 and this is y2. Now I want to call your attention to something here. These are subscripts. They are not exponents. We're not saying x to a power, or let me use this one. I'm not saying x to the second power. I'm saying the second x. So that is not to be confused with this. See the difference? The points are using a subscript. So don't get those confused. That's an easy place to get tripped up. All right, so the first thing I'm going to do is rewrite my formula. Slope is what I'm looking for. And then I'm just going to go ahead and build the framework for my formula. And then carefully, you take y sub 2, which is this value, and you just set it down there in your formula. Bring down the subtraction. Then I need y sub 1. It's like putting together a puzzle. I need y sub 1, and there it is. So 2 minus 4. Now, don't get excited. It's okay. Then I need x sub 2, which is right there, the 2. And then x sub 1, which is right here. It's the 4. You see why I label them. Now we could already tell right here that it's the same on the top and the bottom. It's identical at this stage. So that's going to equal 1 because it's the same top and bottom. But let's follow it through mathematically. 2 minus 4 is negative 2. 2 minus 4 is negative 2. Don't let the negative signs get you rattled. We can put those in the calculator if we need to, but we don't need to because it's the same top and bottom. So slope, m, equals 1, positive 1. Now we knew that it was positive because we're climbing the stairs, not coming down the stairs. But that is an example of how to use the slope formula. And sometimes there's no other way to do it. If you can look at the graph and see this perfect stair step, I could tell you before I even started writing that the slope was 1 because I've done this for so long now. But as you're learning it, you won't be able to do that as easily. You could also tell your slope right here at rise over run because it's up 2 over 2, that equals 1. So we proved mathematically that the slope is 1. I knew it already, and you knew it too, because we found it right here. But it's really important on some of this stuff to understand where the formula is derived, where it comes from, relating to the graph. Now, if you are confused at this point, I would stop the video, go back to your instructor and say, I really need to learn more about slope before I proceed with this functions class. Because in my humble opinion, the class that we're about to start is a first semester college level class. It is extremely tough. So you need this background knowledge to be able to comfortably follow what I will do. Okay, if you're comfortable, let's proceed to the next skill to review. So I'm going to bring a graph in here, and I should have done a little work on this first. Bear with me 1 second while I trim this graph down to size. I've had way too much caffeine today. I am a shaky mess, so bear with me. All right, I'm going to go ahead and make a copy of this so I don't have to keep doing that. Whoa, that didn't make a copy, did it? It made a copy of the page underneath, which is not what I want to do. Okay, I guess I won't do that. All right, the next thing I want to talk to you about is the standard form of an equation. Actually, before we do that, let's do one more slope problem, just to have this nailed down very well. So I have a coordinate plane here. There's the x-axis that runs across. Y is tall, it's the vertical, and that intersection creates a coordinate plane. So this time, I'm going to give us a point here, a point here, and a point here. And then I'm going to continue the pattern on the other side of the y-axis. So I'm making basically a mirror image on the other side. Okay, so let's connect the dots. This is tricky for me because I'm using an iPad, so hopefully this will nail it down. It's pretty close. Let me try one more time because that's just not. On these types of graphs, it's very important to be exact because that's really what we're learning, is the whole idea of this slope is constant at a continuous rate kind of thing. But this will do. So let's go ahead and put some of our points in. I'm not going to put them all in. I think I'm going to use this one right here. And so to get to this point, I would go 1, 2, 3, 4, 5, 6 to the right. That's positive 6. And from that positive 6, I would drop down 1, 2, 3. So 6, 3. Negative 3, excuse me. So that's that last point. And then let's get this point. Starting from origin, I will go back 6 spaces, negative 6, positive 3. So I'm just picking 2 of the points on this graph. And before I calculate slope, let's go ahead and look at it from a common sense point of view. So in this scenario, I am rising 1 unit, running 2. Now direction doesn't matter. What we're looking at is the absolute value of the rise and the run. So here I'm rising 1, running 2. I'm rising 1, running 2. So you see that my steps this time are doing what? They're going down. This is a negative slope. The plane is landing, in other words. Okay, if you want to continue the pattern, you're going to drop down 1. Right here's the drop. There's the run. Then you are going to drop down 1, let it run 2, and then 1 more. So you see that those steps are going down, and they're going down at a constant rate. That's what's so important. You don't have one step that's out of order or that's bigger or smaller. They're dropping at a steady, constant rate. So I can go ahead just looking at this graph and tell you slope. If I remember the concept of rise, which is the y value, over run. So each step is how tall. How many boxes does that cover? Just 1. And it doesn't matter which step I look at, it's still just 1 box tall. So that's the rise. There is a 1 box rise. And then running, how wide is the step? How much do I have to step on? Well, there's 2, 2, 2, 2, 2. Run is 2 in each step. So there's your slope. You don't even have to do the formula if you know it. But there's one thing missing that the formula will tell you. You have to remember that this is a negative slope because we're going down the stairs. So if you're going to use rise over run, use the negative if you need it. Compare these 2 graphs visually. In the top one, I'm down in the basement climbing up. In the bottom one, I'm upstairs going down to the basement. That sign is absolutely critical. This first graph had a positive 1 slope. It was positive. This one is negative. So when I was in school and my professor said, tell me the slope, and there was a graph there, I just did rise over run. But then my professor said, tell me the slope and show your work. And that's when I had to know my formula. So let's go ahead and work it using the formula. It is rise over run. That doesn't change. The y's are on top, the x's are on the bottom. And remember, it requires 2 points. Now, I could have picked any of the points on this graph, but since I have these labeled, I'm going to go ahead and label them a little bit more. I'm going to be x1, y1. Those go together. And then these go together as x sub 2, y sub 2. But those values are going to go into this formula to help me. And I always like to work down the page. Some people like to work across. It doesn't matter. The thing that matters is that you get the values in the right place. So y sub 2 is negative 3 minus y sub 1 is positive 3. Now that's not going to equal 0. Then x sub 2 is 6. and y sub 2 is negative 6. Again, that will not equal 0. If you need to put this in your calculator, that's fine. But we're going to focus right here for just a second. Nowhere else but this spot. So I was already 3 in the hole, and I went 3 deeper in the hole. Now I am at negative 6 in the hole. If necessary, put that in your calculator. Don't make a mistake right there. Put it in the calculator and see what you get. Okay, this one, I was at 6, and then those two negative signs together become a positive. So 6 plus 6 is 12. Again, put that in your calculator if you need to. And then what do you know about 6/12? 6 into 6 is 1. Keep the negative sign. And 6 into 12 is 2. And look at that. We already knew that. I can look at the graph and tell you that. It just depends on whether or not you have to use your slope formula. So there's an example of a positive slope and a negative slope, and what that literally looks like in terms of our staircase. I think I'm going to stop this video before I do the next step because that's getting very long. So I'll see you back in just a second for the next piece.